Hello, my name's Richard Cowling, and I live at Cape St. Francis. I've been involved with foster for decades now. This is the second presentation in a series of presentations on the foster Friends of the St. Francis Nature Areas reserve systems. You can see all the reserves on the left-hand side of the slide. What I'm going to do in this talk, which is part of setting the scene, providing background, is focus on the flora, describe its characteristics, and emphasize particularly its very special features. Just to recap, the vegetation in our area is Struntfelt, which is a mixture of fynbos and subtropical thicket. Struntfelt occurs along the coast in a tiny, narrow band of recent or Holocene dunes between Algoa Bay and the Longabon area. It covers a very small portion of the Cape Floristic region, about 1.2%. Secondly, we sampled an area of about 803 hectares in order to compile the flora of our region. We focused in protected areas, so we looked at the four reserves in the four foster reserves. We also looked at Rocky Coast Farm, as well as the Lynx Reserve, which included a bit of the Oyster Bay bypass dune. The flora of our region has been published in an online research paper, peer-reviewed, produced by myself with huge input from Greater St. Francis residents Carol Logie, Joan Brady and Margie Middleton, as well as from a student at NMU, Adrian Grobler. This paper can be downloaded for free from this website. And basically it summarizes everything one would need to know about the flora, probably lots more detail than many of you would need. And it also includes a list of all of the species in our area. So let's have a look at the size of our flora. Firstly, there are 402 species in total. That's extremely rich, I must tell you, for a dune area, and I'll show you later on. Nearly half of them are endemic to the Cape Floristic region, which suggests or indicates that our flora is a Cape flora. 30% of them are restricted to these Holocene dunes. They grow only there and nowhere else. And 8% have been classified as threatened in some way. 40% of the species occur in fynbos. So fynbos harbors by far the largest number of species in our flora, the fynbos component of Struntfelt. But 16% of species occur in thicket. This is a high amount because these are all species of subtropical or tropical origins. Many have distributions that extend deep into the tropics of Africa along the coast and elsewhere. Regarding the other major habitats, 13% of species occur in wetlands. We have a very rich wetland flora in our region and an interesting array of wetlands, some of which are unique globally. 10% of species are strictly coastal. These are species that are confined either to the mobile and semi-mobile dunes of the coastline or else to the rocky coast, which is subject to salt-laden winds throughout the year. So these are the real hardcore coastal species that grow in these habitats and nowhere else. 9% of the species are forest species, although forest covers a very, very tiny part of our region, probably less than 1% or less than 0.5%. Yet we still have a rich forest flora, which is fascinating. And 7% of species occur in the grasslands of the high water table dune slacks. Just to emphasize that these grassland species are true grassland species growing well into the summer rainfall areas of the eastern seaboard. Next, we're going to look at the special species in our flora, the species for which our reserves play a very important role. These include, firstly, those species that are endemic to the dunes of the southeastern Cape, an area roughly from Knysna to Algoa Bay. As I pointed out before, very small sliver of habitat. And in our flora, 60 species are thus classified, 15%. And as I've said already, these are the special species, the ones that our reserves are really important for conserving. The second group of species are those species that are classified by the botanical authorities as being endangered with extinction. In other words, they're listed in the red data book. Warning signals or alarm bells go out when we see these species because their populations are dwindling and they are vulnerable to extinction. We have an extraordinary 32 species that are red listed in our region. That's 8% of the flora. Some of these species are also endemic to the dunes of the southeastern Cape, the previous bunch that we looked at, but others are more widespread. They may extend into the east, into the Western Cape, or even up to KZN, but they are extremely rare throughout the distribution of their distribution, and their populations are declining. So exactly how rich is our flora compared to comparable geographies elsewhere in the world? In other words, dune regions in areas that have dry summers like ours. And as an example, I've taken a dune flora from Southern California. This flora comes from a region with a similar diversity of habitats to our own. We can see the equivalent of fynbos in the first slide, as well as thicket in the background, a variety of dune plants, wetlands, and so on and so forth. This area is the Guadalupe-Napomo dunes, north of Santa Barbara, and there are 140 species in 1,030 hectares. That's a much larger area than ours, and we have about nearly 3 times as many species as in California. This is fascinating. Our dune floras are extremely rich, and we need to ask the question, why? So now we're trying to understand the huge diversity of this dune flora, ours, as well as the diversity of dune floras elsewhere in the Cape, and trying to demystify this puzzle. Now, the first intriguing thing is that, as I've said already, our flora forms part of the Strandveld biome that occupies this tiny, tiny sliver along the coast of the Cape Floristic region. Now, this occupies only 1.2% of the Cape Floristic region, but there are 275 dune endemic species, in other words, species that are confined to this tiny sliver. How could such endemism evolve in such a small area? Well, let's see. The answer lies in the climatic fluctuations that have occurred over the last 2 million years or so in the Pleistocene period. Now, Pleistocene is characterized by some of the most dramatic climate fluctuations that the globe has ever seen, where conditions change rapidly from interglacials, like now, when the climate is relatively warm, to glacials when the climate is much colder. This slide shows the sea levels on a typical interglacial, the conditions we experience now, going from Mossel Bay area to PE, and you can see that the sea level is more or less where it is today. However, during full glacials, the coldest periods during the glacial times, lots and lots of ice or lots of seawater was bound up in ice, and therefore sea levels dropped. And in places that had large offshore shallow banks like we have south of the Cape, vast areas of land were exposed. So in our region, in the Cape, an area the size of Ireland, about almost the size of the existing Cape Floristic Kingdom, was exposed. And the coast in present-day Mossel Bay was about 100 kilometers south of what it is today. And then south of De Hoop area and towards Cape Agulhas, the coast was almost 200 kilometers away. So here we have in the top panel the distribution of Holocene dunes with the associated Strandveld vegetation, and as we said, occupying a very small part of the Cape region. And what we have below is the exposed Paleogallus plain during a glacial. And this has been mapped by a good colleague of mine, Hayley Cawthra. And what she found during this offshore mapping, which, as you can imagine, was quite a difficult task to undertake, what she found is that there was vast areas of sand dunes on this coastal plain, stranded by various sea level fluctuations, huge areas of sand. So there was an 23-fold increase in the extent of Strandveld in the last ice age. So Strandveld, now occupying this tiny sliver, then occupied a huge area. And that in itself can begin to explain the massive richness that we have in our dune flora, because this flora has a large area and lots of disjunct patches of dune that were exposed during that period, in which species could survive, their populations could be large, and speciation could occur. And then when the sea level rose, these populations were all swept to this tiny little refuge now existing on our coast. So getting back to the mystery as to why the California dune flora is so poor in species, the answer, we believe, lies in the fact that there was no such offshore plain during glacials on the California coast. The blue in the map of California that you can see on your screen represents the areas that were exposed. And these were tiny compared to the Cape, tens of kilometers wide at the most. And the extent to which these offshore plains actually supported sand dunes is not yet known. But even if a lot of the area was covered by sand, it's still not a massive area to sustain populations of many, many species of dune plants. The reason for this is that California is tectonically unstable. It's currently moving, the two plates are moving at a rapid rate past each other along the San Andreas Fault. And this is causing all sorts of subductions and what have you that would preclude the formation of very long-lived offshore coastal shelf. So the California flora is poor because it never had, during these glacial periods, a large area of dune which could sustain diversity. So let's sum up. Firstly, our flora is rich in species. I hope you appreciate that. We have a very rich flora and therefore a big responsibility to conserve it. Secondly, ours is a Cape flora, but we have lots of tropical stuff. And that's unusual for dune floras at our latitude, but that's another story. Thirdly, sea level fluctuations have been very important. They've been important in exposing large areas of dune, enabling the dune flora to expand, but also in restricting the dunes to these tiny slivers, which can bring about extinctions, but also speciation. So you can get closely related species occurring in, say, the Eastern Cape dunes, the Western Cape dunes. There were probably once a continuous population, but when the sea level stranded them in different geographies without interbreeding, they evolved into new species. There are many examples of these. And we're dealing with a saturated flora. A tiny sliver, as I said, is harboring a flora that once occupied a much larger area, and as a result, we've got many, many rare species. And therefore, our reserves play a really important role in conserving this flora. Thank you very much.